So this question gives us f of x is 1 over x minus 3 squared plus 2. And we want to use transformations. So we're doing a shift. So what is the shape of this graph? The shape of this graph is y equals 1 over x squared, and then shifted right 3, shifted up 2. So let's look at our shape diagram. Zero doesn't make any sense, but I can go to 1. 1 over 1 squared is 1. 1 over negative 1 squared is 1. 1 over 2 squared is a quarter. 1 over negative 2 squared is a quarter. 1 over 3 squared is a ninth. 1 over negative 3 squared is a ninth. So that's what we're starting with, and we have an asymptote at 0. So let's look at those points, and then from there we're going to shift everything 3 right and 2 up. So let's jump to Desmos. Let's put those points on there if I can. To Desmos we go. So let's go ahead and put those points on. So this is for the shape. So we get 1 comma 1, negative 1 comma 1, 2 comma a quarter, negative 2 comma a quarter. And my window is no good here. Let's go back to the home window. And then we're going to have 3 comma a ninth. And negative 3 comma a ninth. And you know what? It might be helpful to add one more point here. Whoops, I just erased all those. And they're back, thankfully. Trying to erase that last comma. Oh no, it's not the last comma. Okay, good enough. I would like to maybe have a point at a half. So let's take a look at that for a minute here. So these were our values. How about a half and negative a half as well? 1/2 and negative a half. A half squared is a quarter. 1 over a quarter is 4. Negative a half squared is a quarter. 1 over a quarter is 4. So let me add those points as well, just so I can get a couple more. So a half 4 and negative a half 4. That gives us a better idea what this thing looks like, I think. So from there, we want to shift everything 3 to the right and 2 up. Shift everything 3 to the right and 2 up. So what are my points here? Here's my first one, is 1, 1. 3 to the right and 2 up. You can see what we've done. How about my point 1, negative 1? 3 to the right and 2 up. And I can do that with all of these others. So I'm going to just copy and paste all of these. So 3 over and 2 up on all of them. 2 up. 3 over. 2 up. 3 over. 2 up. 3 over. 3 over, 2 up, 3 over, 2 up, 3 over. It's a little tedious. You're on Desmos, and there you go. So there is my new set of points. And what is that supposed to be? Those red dots should make up the equation y equals, or f of x equals 1 over x minus 3 squared plus 2. So let's take a look at it. F of x equals 1 over x minus 3 quantity squared and then add 2. Does it go through all those red points? And indeed it does. Now looking at this, let's talk about the domain and range of this thing. So in terms of domain, what point do we have to stay away from? What point is never on the graph? What x value doesn't show up on the graph? Well, remember, to do domain, you know the bottom cannot be 0. So I have f of x is 1 over x minus 3 squared plus 2. The bottom cannot be 0. You cannot divide by 0. So x minus 3 squared cannot be 0. So x cannot be 3. So in terms of my domain, domain is everything except 3. So remove 3. Everything to the left is there. Everything to the right is there. So in terms of interval notation, that's negative infinity to 3. Union 3 to infinity. Now what about the range? Range is a little harder, but I think if you look at Desmos, you can see what it's going to have to be. Y values never get below what? Y values never get below 2. And the Y values never can actually equal 2, but they can get as big as you want. And maybe you can see why. Because my function is 1 over x minus 3 squared plus 2. X minus 3 squared is always positive. 1 over a positive number is always positive. 2 plus a positive number is always more than 2. So the range is everything from 2 bigger, but not including 2. So the range goes this way. So the range in interval notation would be parentheses or round bracket 2 comma plus infinity. The plus is obviously optional. That'll do it for that problem.